Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about closed loop transfer function or overall transfer function for positive feedback control systems. This is linear control systems, lecture series on linear control systems, lecture number 19. So our target closed loop transfer function or overall transfer function calculation for positive feedback closed loop control systems. Then canonical form of positive feedback control systems. What is the positive feedback closed loop control systems? R of S reference input, and this reference input may be step, ramp, parabolic, impulse, sinusoidal, analog, digital, any type of input you can apply. And this is the comparator or summing point. And this summing point always positive because forward path or forward signal always positive. And output of the comparator signal is E of S. And this is called actuating signals or error signals. And this is the input of control elements and control systems. And the gain of the control system G of S. And overall output equivalent to C of S. So C of S is called the overall output, and this is the effect of the systems. And R of S is called the reference input or set point. This is also called the cause of the systems. And this path is called forward path because in this case only forward direction. R of S forward direction. This is positive. E of S systems plant input, and G of S output also forward. That's why this path is called forward path. And in this case, the forward path transfer function and next, this is the feedback, and feedback element equals to H of S. And this is the feedback path. And obviously this feedback, primary feedback gain equals to B of S and the feedback signal plus. That's why this type of closed loop control system or this type of feedback control system is called positive feedback control systems. Positive feedback control systems. And RS equals to reference input or control variable. C of S equals to controlled output or control variable. R of S is also called cause, and C of S is also called the effect. And E of S equals to actuating signals or error signals. And G of S equivalent to forward path transfer function. Forward path transfer function. And G of S equals to forward gain or forward transfer function, and H of S equals to feedback transfer function. So what is the forward path transfer function and what is the feedback path transfer function? That means GS and H of S. So next target, forward path transfer function, our basic concept of forward path transfer function. This is the block diagram. Reference input, actuating signal E of S, and controls elements G of S, controlled outputs CS, and the feedback or measurement element H of S, and primary feedback gain V of S. So the forward path gain, forward path transfer function equals to what? Forward path transfer function G of S equals to G of S equals to C of S divided by E of S, because this is the forward path. This is the forward path. And for this forward path, output equals to C of S, input equals to E of S, and the gain equals to, or transfer function equals to Z of S. So Z of S equivalent to what? G of S equals to output CS by E of S. Or CS equals to what? CS equals to GS into E of S. This is the forward path transfer function. Next, feedback path transfer function. This is the positive feedback, and feedback element equals to H of S, where H of S equals to gain and B of S equals to output of the system, and C of S in this case input. So C of S input, system gain or transfer function equals to H of S, and output equals to B of S. So H of S equals to what? H of S feedback transfer function equivalent to output by input. Transfer function definition, Laplace transform of output, that means B of S divided by Laplace transform of input. All initial conditions are zeros. In this case, B of S equals to what? HS into CS. Just multiply HS into CS equals to primary feedback gain. Primary feedback gain. So feedback path transfer function equals to H of S equals to B of S by C of S. This is the feedback path transfer function concept. Then open loop transfer function for a closed loop systems. This is the closed loop and positive feedback systems. For this system, what is the open loop transfer function? This is the very important for stability analysis. Open loop transfer function means product of the forward path gain G of S and feedback path gain H of S. It's called the open loop transfer function. So open loop transfer function, ratio of the output of the feedback path B of S to the actuating signal E of S for any given feedback loop. In this case, open loop transfer function equals to primary feedback gain B of S. This is the primary feedback gain B of S, or feedback signal B of S, divided by E of S actuating signals or error signal. This is equivalent to what? This is equivalent to CS by ES into BS by CS, because if CS cancel, again BS by E of S. So this is the form. Then C of S by E of S equals to what? CS by ES equals to output for forward path transfer function. C of S equals to output, A of S equals to input, and the gain equals to Z of S. So this is equivalent to, first term equivalent to Z of S. This is equivalent to G of S. And second term B of S, output by input. This is the output B of S, and input equals to C of S, equivalent to H of S. So this is equivalent to, second term equivalent to H of S. Then open loop transfer function equals to product of the forward path. This is the forward path gain and the feedback path gain, is called the open loop transfer function. GS into HS is called the open loop transfer function. Then overall transfer function. This is actually our focus or our target. What is the overall transfer function? For a closed loop positive feedback systems, system output C of S. So C of S output divided by input, reference input R of S. Reference input R of S. Output by input, Laplace transform of output divided by Laplace transform of input, and all initial conditions as zeros is called the transfer function. This is the overall transfer function. And what is the value of overall transfer function? This is our target. So this is equivalent to, actually, the ratio of CS by RS is called the closed loop transfer function, and the closed loop transfer function CS by R of S equivalent to GS by 1 minus Z of S into H of S. But how? It is the closed loop transfer. Why it is closed loop transfer function? Prove that CS by RS equals to GS by 1 minus GS into HS is called the closed loop transfer function, where 1 minus Z of S into H of S equals to 0 is called the characteristics equation. And this characteristics equation gives the pole's position or pole's location. And if all the poles and zeros left hand side of the S plane, then system will be stable. So this is also very important for positive feedback closed loop systems. The overall transfer function CS by RS equals to GS by 1 minus GS into H of S. Then canonical form of closed loop control systems. This is the control system block G of S, and actuating signal E of S and controlled output C of S. Then G of S equals to what? G of S equals to G of S equivalent to C of S into E of S, or C of S by E of S. Sorry, this is the C of S divided by E of S, output by input, equivalent to G of S. And again, C of S equals to what? C of S equivalent to controlled output equivalent to planned gain E of S, or actuating signal or error signal equivalent into G of S. This is the controlled output for forward path gain. For forward path, output C of S equivalent to E of S into G of S. This is the concept. Then from figure, C of S equals to what? G of S into E of S. G of S into E of S. This is the equation number 1 for forward path transfer function, or this is the open loop transfer function. And then connect reference input R of S with a comparator or summing point, and this path always positive, and connect one feedback for high accuracy. This is the feedback element H of S, and the feedback gain, primary feedback gain B of S. This is the feedback signals. And from this closed loop positive feedback, this is the positive feedback systems. The second equation, the transfer function of the closed loop system can be reduced as follows. E of S equals to what? E of S, that means actuating signals or error signals equivalent to what? Reference signal R of S plus B of S, primary feedback signals. So actuating signals, error signals equivalent to RS, reference input, and plus B of S. So this is equivalent to RS plus B of S. This is the equation number 2. And third equation, B of S equals to primary feedback signal equals to CS into H of S, because this is the input C of S and output B of S, and H of S equals to what? H of S equals to output B of S divided by C of S, and B of S equals to what? H of S into C of S. HS into C of S is called the BS signal, primary feedback signal, CS into HS. This is equation number 3. Then this is equation 1, 2, 3, eliminating BS from equation 2 and 3. That means this is the equation number 2 and this is equation 3. And from equation 2 and 3, eliminate B of S. This is B of S. This is also B of S. So put equation 3 in equation 2. Put here B of S, and we get E of S. This is the equation number 2. Left hand side E of S equals to R of S, reference input, plus B of S equals to what? B of S equals to CS into H of S. Where B of S equals to CS into H of S. This is equation number 4. B of S equals to CS into H of S. Put here just CS into H of S. This is equation number 4. This is the very important equation. Then from equation 1 and 4, eliminating E of S from equation 1 and 4. This is equation 1 and this is the equation number 4. Eliminating E of S. That means this is the E of S for equation 4 and this is the equation 1. And this is the E of S. Put here E of S equivalent to RS plus CS into HS. RS plus CS into HS. This is the value of E of S. Put here. Then we get CS left hand side, right hand side G of S, and E of S equals to what? RS plus CS into HS. RS plus CS into HS. And multiplying GS into RS plus GS into CS into H of S. This is the output equation. Controlled output C of S equals to G of S, R of S plus G of S into C of S into H of S. Then repeat just equation C of S equals to G of S into R of S and GS into CS into H of S. Then left hand side CS and just shift right hand side to left hand side. This is the term, and plus this is the minus sign. So again, this is equivalent to GS into R of S, G of S into R of S. So CS minus, this is minus GS into CS into HS equals to G of S into R of S. Just common C of S, first equation. This is the C of S. This is also C of S. So common C of S, and we get 1 minus, this is the 1 minus GS into S of S into C of S equals to GS into R of S. Then CS equals to what? The controlled output CS equals to GS into RS divided by 1 minus GS into SS. This is the controlled output response for positive feedback closed loop control systems. And this is the characteristic equation 1 minus GS into SS. Then divide both sides by R of S, and we get controlled output C of S divided by reference input R of S. This is called the transfer function, overall transfer function or feedback path transfer function equals to what? GS by 1 minus GS into S of HS. So this is the transfer function, overall transfer function for closed loop positive feedback control systems, where denominator terms 1 minus G of S into S of S equals to 0 is called characteristics equation. And this characteristics equation gives the system stability of the systems. Then positive feedback closed loop control system. This is the positive feedback control systems already discussed. And for positive feedback system, the transfer function is a CS by RS equals to GS by 1 minus G of S into S of S. And the single block is as the block diagram, single line block diagram, that is the R of S reference input. R of S, this is the R of S reference input, and the block gain GS by 1 minus G of S into SS. This is the block gain, and output C of S. Then C of S by R of S, CS by RS equals to GS by 1 minus GS into SS is called the positive feedback overall transfer function. Positive feedback overall transfer function. The negative feedback closed loop control systems, just feedback signals negative, otherwise everything same. So this is the feedback signals and this is the negative feedback. That's why this type of feed control systems or this type of block diagram is called the negative feedback closed loop block diagram. Hence, the above feedback system can be reduced to a single block shown in figure below. RS GS by 1 plus GS SS. In this case, they are negative. That's why this is positive. This is the positive value. Then the transfer function CS by RS equals to CS by RS equals to GS by 1 plus GS into S of S. Then positive negative feedback control systems. If positive negative, just change for positive or concept, this is the negative. And for negative value, this is the positive value. This is the positive value. For positive negative closed loop systems, for positive and negative system, the transfer function is as CS by RS equals to GS by 1 minus plus GS into S of S, where R of S reference input, G of S by 1 minus plus GS into SS, and the output controlled output C of S. This is the single block. This is the single block. Then unity feedback, negative or positive control systems. Unity feedback control system is where H of S equals to 1. H of S equals to 1. Just H of S equals to 1. H of S equals to 1. This is called the negative positive unity feedback closed loop control systems. In this case, just CS by RS equals to GS by 1 minus plus GS. In this case, SS equals to 1. And the block diagram, RS reference input and the GS by 1 minus plus GS, and the reference output equals to, or controlled output equals to C of S. So this is the unity positive negative feedback control systems. This is the unity positive negative feedback control systems block diagram. Concept of the characteristics equation. For positive feedback system, the transfer function is as CS by RS equals to, already discussed, GS by 1 minus GS SS, and denominator terms 1 minus GS SS is called the characteristics equation of the systems. For negative feedback systems, the transfer function is as CS by RS equals to just GS by 1 plus GS into SS. In this case, this is the positive value, and the characteristics equation is 1 plus GS into SS. For positive and negative transfer function, what is the concept? For positive feedback, this is negative, this is negative. That's why 1 minus something, this is the value, low value. That's why the ratio GS by 1 minus GS SS or CS by RS ratio high, or transfer function ratio or efficiency ratio high. But for negative feedback control systems, this is the positive. So that's why this terms less. This is not less. This is not less. Again, this is negative. This is negative. This is negative. That's why this is less value. This is the less value. And the ratio is maximum. But in this case, this is positive. That's why 1 plus G of S, H of S, large value. But in this two ratio, GS by 1 plus CS SS is less. That's why CS by RS value minimum. Controlled output by reference input ratio minimum. This is the effect for positive and negative feedback control systems. Thank you.